Hello there. Today I'm going to try to demonstrate the solution to a question that appeared in the Indian National Astronomy Olympiad 2017. Let's take a look. Okay, so the question says that if Mr. Anthony has two children and we know that one of them is a boy because he came to greet us at the door, then what is the probability that the other child is a girl? And the second part of the question says that if the boy claims to be the elder one, then what is the probability of the other child being a girl? Now, the answers claim that in the first case it should be 66% and in the second case it should be 50%. I believe that this is slightly inaccurate. First of all, we'll try to understand the model solution and what it claims, and then we'll try to understand an alternative way to think about it, as well as where I believe that the solutions went wrong. Okay, so they suggested that the four possibilities are boy, 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 girl, girl, boy, and girl, girl. And of course it cannot be girl, girl because we know that one of them is a boy. So we have got three possibilities and two out of them have a girl in them. So it's 66% or 2 by 3. In the second case, if the boy claims to be the elder one, there are just two possibilities and the probability is 50%. The second part is obviously correct. But what I want you to remember is that this part B, the answer from part B, would be very crucial in solving the part A. Okay, so let's take a look at my solution. So the boy we saw may be younger or maybe the elder one, the elder of the two siblings. Okay, so we have already seen this question being asked in the part B. So if he's older, he may have a younger brother or he may have a younger sister. 50% and 50% odds. Okay, so this is in confirmation with what the model solutions say. We again extend this logic similarly to the possibility that he may be younger, and again the possibilities of having an older brother or an older sister will be 50-50, and because there is a 50-50 odds of him being either younger or older, so we get 25, 25, 25 and 25 of the whole in the four boxes: older brother, older sister, younger brother and younger sister. Now let's put all of these cases into a list. So he has a younger sibling 50%, older sibling 50%, and younger brother 25, younger sister 25, elder brother 25, elder sister 25. Again, this has to be true because this is just an extension of the logic laid out by the second part of the question. So the cases that are still possible are boy boy, younger brother, boy girl, younger sister, boy boy, older brother, and girl boy, older sister. Now, we have to note that there are two boy-boy pairs over here. This is because there are two possibilities, there being a younger brother or there being an older brother. Once we know that we know one of these boys, the orange one over here, these two cases become different. Initially, they were the same thing and there was just one boy-boy situation. However, this is the beauty of the problem, that as soon as we know one of the boys, these two boys stop being identical and actually turn out to be two different probabilities. Now, a simpler way to think about this is just to forget the ages, because the ages do not matter. And if we forget the ages, the three possibilities that can occur are boy boy, boy girl, and girl girl. We are not permuting these two around because we do not really care about the ages right now. And out of these probabilities, this one is obviously not going to happen, and there may be a boy boy or a boy girl giving us a 50-50 odds. In this case, it's very easy to see that the answer has to be 50%. However, my reasoning with the four cases also holds why the original reasoning of the question was slightly inaccurate. Next, let's proceed to why the question went wrong. So, as long as there are four possibilities and boy boy is obviously a symmetrical pair, so we do not need to permute them, there is just no point in thinking any further. These are the four combinations and they're very correct. However, as soon as we know one of them, it is very important to permute them, and because they are now dissimilar to us. And again, this is a very beautiful idea in this problem, that once these two boys are slightly different because we know one of them, they are permuted, just the way we are permuting them when they are a boy and a girl and a girl and a boy. And this is what creates the four cases even in our restricted problem. Finally, we come to the key idea which fuels this entire thought process. that no information about the age or the gender of one individual can in any way affect the 50-50 probabilities of the gender of another. And math has to conform to this, no matter what. There will always be a 50-50 probability of genders. Now I'm going to try to analyze some other problems which are quite close to this one and carry the same idea. These are known solutions from which I'm deriving this idea. So this is a story of a Las Vegas casino where the roulette wheel had 27 blacks in a row. Now all of the people from, say, the 10th throw started thinking that there has to be a red. The probabilities of there being a red are constantly increasing. But they were wrong. The probabilities stayed 50%. 50% for red and 50% for black. The probability of the entire sequence existing obviously was rapidly decreasing with 2 to the power negative whatever number of throws there were, eventually 1 by 2 to the power 27, a very low number. But any given throw, any exclusive throw, being red or black, is still a 50-50. And needless to say, people who miscalculated this lost a lot of money that day. Similarly, if we extend our own question to there being 3 children and 2 of them being boys, we see from this solution here, this enlistment, that there is a 75% chance of there being a girl if we believe the idea put forth in the model solution. What if there were 4 or 5 or 100 different boys we saw, and then if we ask the probability of the 101st, actually 4 or 5 or 100 children, and we ask the probability of the 100th, if we saw 99 of the boys, what would be the answers? And the answers would be continuously increasing fractions, because we are again making the same mistake that we made in the roulette wheel by thinking that the average percentages have to come out to be 50. That is not true. The individual exclusive percentage has to be 50, and it does not depend on anything else. Of course, this is an extremely beautiful idea and a very instructive mistake that was made. I believe that all of us missed to see this idea during the exam, and I was very impressed by this, by the beauty of this question and this spontaneously occurring case of boy and the other way around. And I do believe that it's a very interesting and instructive question, and that everybody should take a look. I do hope that once the people at the Astronomy Olympiad see the solution, they would agree to change their answers, and I do hope that I am correct as far as my answer is concerned. I have not left out anything. I may have made a mistake. If I have, please leave it in the comments below, and tell me what you think of the video. Thanks a lot.